Hi guys. So this is the last lab for the course, and as such, we don't have any specific topic to do. So what Katie sir has told me to do is to cover like a series of topics that would be useful in general. Uh, so it's not specific to any topic. Like last time we did GANs, we're not doing any architecture as such this time. So we have three things on the agenda for today. And yeah, first of all, I hope I'm audible. So the first thing that we need to do is to see how we can deploy. Okay, thanks. Yeah, so the first thing that we need to do, so assume you train an image classifier or any kind of model, uh, and you want to deploy it, and you want to make a very simple application for it. And so how do you go about doing that? So for that, we'll use a very simple uh, platform called Gradio, and you can deploy. All you have to do is you have to implement a predict function, and then you can just pass that function to Gradio's API, and it does everything for you. So we'll see that. So that's the first thing on our agenda. Second thing is, so when you're training machine learning models or deep learning models, you have a set of hyperparameters. You have learning rate. You have all kinds of hyperparameters, and uh, you'll be trying to fine tune your hyperparameters. In the sense, you'll be trying to find the best set of hyperparameters that works best for whatever you're trying to do. So when you're doing that, you'll be running multiple experiments, and it is a good idea to keep track of these experiments. I mean, either you can do it manually, you can have an Excel sheet where you put in the hyperparameters and your observations, but then that is not really a practical way when you're running dozens of experiments. So for that, we'll look at a library called Guild AI, which is basically plug and play. It's a single line of code basically. It'll let you do that without any additional code. And finally, the last thing that we need to do is, in case you come across multiple GPUs and you want to make use of this additional hardware, then the typical PyTorch code that you write will not work out of the box. So you'll have to make slight modifications to it to make it work with multiple GPUs. So we'll also see how that is done. Okay, so we'll go from like easiest to hardest. I mean, it's not really hard, but then the simplest thing we'll do first. So the first thing, okay, so I need a. The first thing we look at a basic, how we're gonna um, deploy a model. So let me get your notebook. So if you go to the website for Gradio, right? So basically, you'll be using something called an interface, and this is their high-level class that you can use to create any kind of interface for. Uh, in our case, so let's say we're dealing with an image classification model. So in that case, the input to our image will be an image. Input to our model will be an image, and the output will be a set of values corresponding to each class. And in that case, our inputs, we can just give it as image, and our outputs will be labeled. And so similarly, like there's a huge variety of different input and output components. That's what they refer to it as, components that you can use. And it's in a single line of code, you can create a kind of an application that runs that runs on their their public server, which you can then access. So you can share the link to a friend and have them test out your dog versus cat classifier. Right. So this is extremely simple. I'll just run it for you. I mean, you can look at the documentation. It's like uh, pretty straightforward, and it's not complicated at all. And so we'll just do the same thing, but then so that you can see it real time. So firstly, we'll have to install the library, which is Gradio, and then we'll need a model. Oh wait, so let I should probably. Uh, we have connected to a neuron type. Would you like to? Okay. Okay. So while that is running, we'll need a model that is going to take in our input, which is with the.
Abhijit, you are not sharing a screen.
Oh my God. Okay. Yeah, that is awkward. Usually, I should have reminded me about that earlier. Okay, that's fine. It's fine. So I guess you must not have seen anything that I showed till now. No. Okay. So yeah. So I was showing you the documentation. I mean, so in the recording it will be there because I'm sharing my screen. So if you guys missed that part, you can go back and look at it. But then I was just showing you the documentation for Gradio, which is again a platform that you can use to easily deploy. I mean, a not really scalable, but a very simple demo or yeah, for your whatever kind of machine learning model that you're making. So in this case, in case you have an image classification model, your input to the image classification model will be an image. I am sharing now, right? Okay, great. Yeah. I don't want to do it thrice. So yeah, the input to your model will be image. The output will be a set of labels, and you have a set of components here. So yeah, I mean there are different kinds of inputs that you will be passing to your model depending on what you're doing. So like it supports various kinds of stuff. It even supports HTML, video, audio, time series data, whatever you want, you can pass to your model, and you can get any of these as output as well. You just need a function that implements that. So in our case, we'll have a predict function which takes an image and returns a label, and you just need to implement this function. I mean, use this class interface class, and it'll do everything automatically for you. It'll create an app, and it'll deploy it on their public servers, and you can just yeah go to the public. Okay, so it's okay. So I was installing the uh, library. Yeah, so that's done. So now what we'll do is I'll just I mean we don't really need a we need to train a model or anything. I'll just use a pre-trained model from Torch Hub. Uh, you can use a ResNet which is trained on BizNet, I guess. Uh, 0.6. Use ResNet 18, so it will be pre-trained on yeah ImageNet. So we do not have to do anything. So yeah. Okay, so we have our model, and now so once we have an image, so the interface. So when you upload an image to the interface, it will pass it as a. So there are options as to how you can pass your image. So if you go to image, you can pass it as a NumPy array. You can pass it as a PAL image object. You can pass it as a path, file path, so on. So in our case, we'll use a PAL image or NumPy array. Let's see, and so our image will be passed as a NumPy array or as a PAL image, and our function is supposed to take that and return the labels corresponding to whatever class we are outputting at. Okay, so first thing we'll need the classes, right? So the ImageNet classes. So ImageNet classes is there are here, right? These are the ImageNet classes. So I'll just download that to the instance, and I'll just mm, yeah make an array out of this so that you can. So finally, when you return your finally in your application, you do not want to return indices. You rather would have the actual name of the labels. So I thought, why not? So so we need a few libraries for that. Yeah, and the transforms. Yeah, so all I'm doing is I'm getting the file and then I'm splitting it with new lines so that I get a list of the individual labels. That's it. So if you look at labels, yeah, labels. Okay, so now we'll create a function. All that the function does is it takes the input, which will be mm, PIL image. It'll take the image, it will pass it to the model. It'll first convert it into tensor, then it'll pass it to the model. It'll get the output. It'll get the predictions. Then it'll, apply softmax, whatever, and then it finally returns the label corresponding to the output. So you take your input. Apply input, and then because batch, there is no batch, but you still need a batch dimension. Okay. And pass it to the model. There's nothing new here. I'm just pass it to the model. I don't need the batch dimension anymore. Then I apply a softmax. Because classification, I mean, you guys know all this because we've done classification like a million times already. And then we'll have the actual confidences corresponding to each. So for that, we'll need to, because we are returning a label, we'll return it as a dictionary with a label and the corresponding score or confidence. So we have your confidences. Just return that. So you have your function which is going to do whatever you want to do. I mean, this is in case you're doing sentiment analysis for text, then you'll have an input as text that you'll get again from using maybe text box, and then you'll pass it to your model. You'll do all the pre-processing that we did when we did transformers. If you remember, we did all the pre-processing automatically. You can do that within this predict some function, and then you pass it to your interface. So now the actual interface, which is what we need for the demo, and the function is the function that we just implemented, predict, and our input will be this image here, and we don't need this image, and our type, the input type will be PIL because that's what we want, and our outputs will be a label. We just want don't want all the scores, we just want top 3. Okay, so maybe I should and bracket. Right. Okay, so I mean, in one line you have created an application. Now all you have to do is do demo.launch. Okay, and then you have a no, not that. Yeah, this I guess public URL that you can use to upload images. Yeah, great. So it predicts that it might be a sandbar, it might be a seashore, which it kind of is. I mean, this is also a generated image. I generated this last time when we were talking about diffusion. Yeah. Okay. So the first part of our lab is done, which is deployment. I mean, it's not really deployment per se, but then if you wanted to have like a toy application for your toy machine learning model which you made, then you need to know how to do that, and you can use Gradio for that. That's it. That's the first part. Now the second and third part, we won't really be able to use Colab because it does not work with Colab. Because I mean, first of all, we need to use multiple GPUs. Colab just gives you one GPU, so it's not really, you can't really use Colab. Okay. So we'll use my local machine. Great. So we'll create a file. So first, I think we can look at Guild AI, and that is all. That'll also like take 15 minutes. It's easy. Uh, let's make a. So Guild AI. Let's look at the documentation. Okay. So what is Guild AI? So imagine. So like I was saying earlier, when my screen wasn't presenting, uh, if if so, say you're training a huge machine learning model, and so each training run will be very expensive, and you train your model for hundreds of, I mean, not hundreds, maybe like a couple of days, and you got some results, and now you realized, or you got, or you think that maybe if you change this particular hyperparameter that might work better, and you change it, you run it again, but then you forgot to log your previous run, then you have basically lost like hundreds of hours of training. So Uh, I mean, like every experiment is valuable, right? So every time you do an experiment, the observation is important. I mean, this is true in science. It's general in science, not just in deep learning. And so it is important that you log every experiment. And it's not, really feasible to do it manually, especially when you have like dozens of combinations of hyperparameters that you can tune. And it's not recommended either that you do it manually. So you can use, so there are many, I mean, there are many open source libraries for it. There's something called Sacred. I mean, I actually recommend that you guys check these out, because there's something called Sacred, there's something called MLflow, but I typically use Guild because I'm lazy and it's easier to use this. I mean, at least I have found that it's easier to use this. Maybe you, I mean, it depends, so it's personal preference. So today we'll look at Guild AI, and you'll see how easy it is to do it. So let's go to docs. You don't need Greedy anymore. Getting started with Guild. The first thing you'll need to do is install Guild, and I think I already have, maybe. Okay. Let's see. Install. It's already installed. You have to install the library. Uh, yes, not needed. Yeah. So how do you actually use Guild AI? So imagine you have a train script that's going to do something. So in our case, let's go online and find a script that does, I don't know, MNIST classification. So MNIST classification, PyTorch, GitHub. Uh, this should work, I guess. I mean, any script works. I'm not in the mood to write a whole script, so let's copy, paste. Okay. Mm, so let's see if it's running. I mean, if it's running. If it's not running before we add guild, then there's no point. So let's run. Yeah, it's running. So all you have to do now is you have to do guild run something.py, and it'll automatically do everything for you. So it'll log all the hyperparameters that you're using. So let's, and while it's running, let's go back to the documentation. Yeah. Yeah, you need to pip install the library, which is guild AI. Just the library. I mean, you don't. So I mean, I'm assuming you already have the dependencies. What are you using for your script? So in this case, whatever they're importing, you need to have, and which is just Torch basically. And then you'll also need to have Guild AI. So that's why I pip installed it. Yeah. Okay. So each time you run a script using guild, it automatically does all of this. It creates a copy of the source code. So each time, so like next time you're gonna run an experiment, you might change the source code, and then weeks later you realize, oh, maybe the version of my source code uh, that I was using 2 weeks ago was better. But then the thing is, I mean, yeah, you can use Git for it, but then I mean, you're not gonna push every time you create like small changes in hyperparameters, right? So like, yeah. So I mean, yeah, and you should, but then regardless, if you do not, Guild does it for you. Like it creates a copy of source code each time you run. Each time you run, you do a run using Guild, it creates a copy of the source code, and yeah, okay, that's. And then okay, let's wait till this finishes. I should have kept it for 2 epochs or something, but it's running for 14 epochs. Let's wait. Okay, so once it's done, all I'll have to do is I'll just have to do guild view, and it will show me all the runs that I've done till now for this project. So for this project in this folder, so there's just one file here, and I'm just running it once. But then all the runs that I've done so far, you can see there. You can compare runs, and you can go to the source code for each run. Okay, great, it's done. So if I do guild view, right? Yeah, view. Oh, okay. So it's okay. So I'll have to. So basically, if this was your local machine, it would have been like localhost 55213. So all you have to do is just go to localhost 55213 on your machine. But then because this is a remote machine, so I'll have to 55213. Uh, right. So now if I do localhost 55213, yeah. I mean, you'll only have to do this. Let's like just do localhost 55213. So you can see all the runs that I've done till now. Before, I mean, this is something else. Yeah, something. So you can see all the they've like logged all the hyperparameters that you've used and scalars. So this is where your loss is supposed to come up. So in this script, I guess. So wait, let me look at the script again. In the main function, you're not returning anything, right? So if you return the loss, then they'll log the loss as well, and then you can visualize the loss. You can view it in TensorBoard. You can compare different runs. So once you change the hyperparameters, uh, yeah, once you just change the hyperparameters and you run it again, and then you can compare the runs here. It's pretty handy. Plus, like you have an interface where you can look at different runs, and you do not have to, go through configuration files, and it's a pain. So yeah, and I mean this is just scratching the surface of what Guild can do. You can do all kinds of stuff. You can do so whenever you're doing hyperparameter search, you do grid search. Wait, let me go back. So you see flags. So you can like, oh, so first of all, you can specify. So Guild automatically will parse your training script, and it will look at what all flags there are, and you can pass these flags uh, while you are training. So wait, let me show it to you so you understand what I'm talking about. So let's say you want to run this, but then let's say you want to use learning rate of 0.1 and fine. That's just we look that up. So if you want to use a flag, hmm, I'm sorry for the mixer grinder in the back. There's nothing I can do for that. Yeah, yeah. But so any of these. So if you want to pass in like different values of batch size. So first, like, so if I pass in learning rate is equal to 0.1, comes 0.2. What's gonna happen is it's first gonna run the script on with this value of 0.1, and then it's gonna run with 0.2. In case you want to create like various combinations. So say you want to have second time you want the batch size to be 20, next time you want to be 30. So what's going to happen is it's going to create a cross product of all these combinations, and it's going to okay, that is not what I meant to do. Yeah, if you it will create a cross product of all these combinations, and it will run trials. They refer to as trials. They run trials for like each of these combinations. So you a learning rate of 0.1 with batches of 20, a learning rate of 0.1 with batches of 30, and then a learning rate of 0.2 with 20, and so on. Any kind of combinations that you want, you can do. Yes. So let me try running this. I'm not sure if it will work. Yeah. Let's see. Okay. What is wrong? Invalid arguments. Let me pause this thing. Weird. Maybe. Let me see. I mean, this is how they. I mean, yeah. I mean, I typically use configuration files, so I don't pass in hyperparameters like this. But then this is how they tell you to do it, but then somehow it's not working. Let me see. Uh, let's see if it works with that size, and then okay, that is not working either. I'm doing something wrong in terms of syntax. Do I have to add? No, I don't. I don't think I have to add. No, it's not that. Weird. What function am I calling? I'm calling main. So it should automatically pass this and be able to identify. Weird. That's my. That's fine. Killed. And, okay, I think the problem was spacing. And I don't know. Yeah. So basically what I wanted to convey is that you can pass in different hyperparameters and it'll run. Okay, maybe let me stop this because it'll run 14 times for each. Let me change the number of epochs. Yeah, here it is. What am I doing? What am I doing? Yeah, because I passed in the epochs and I'm okay. Yeah. So basically it'll run first with two epochs, and then the second time it'll run with four epochs. Each time it'll catalog everything, the loss. I mean, not the loss, maybe not the loss because we're not returning the loss. But then if your main function return the loss, then it would catalog that as well automatically, and it'll also keep track of the source code each time. And I mean, this might not seem that useful to you, but then when you want to have like a huge variety of hyperparameters, like tens, dozens of hyperparameters that you have, and then you can just pass in a list of each of these hyperparameters that you want to uh, try out, basically, and then it'll automatically do grid search for you. And it's not just grid search; there are various kinds of different uh, hyperparameter search methods that they have. But then by default, it's grid search, and yeah. And then there's all kinds of stuff that you can. So scalars refers to like what all stuff you want to keep track of during training. So like loss, accuracy, etc. And it is compatible with TensorBoard or anything else that you might want to use. Yeah, TensorBoard, all this stuff. Okay, that's pretty much it. And so, I mean, there's much more functionality. So, like, I again encourage you. I mean, they have pretty good documentation as well, so it won't be difficult to find what you're looking for. And I encourage you to use, at if not Guild, at least any kind of library that keeps that helps you to keep track of experiments. So that's 2 out of 3. Now the last thing that we have to do is DDP, is training on multiple GPUs. So how do I find such libraries? Uh, I mean, these are pretty popular. Like Sacred and MLflow is like very popular. People in industry also use it, as far as I know. And Guild, Guild is just for lazy people. I mean, it's easier to use, and plus they have like all kinds of. So one thing. So for people who do not want to do all of this stuff through the command line interface, they also have a Python API. So you can have like functions inside your code. I mean, so when you use the command line interface, you do not have to change your code. But then if you want my like more fine grained control over what it's doing, then you can use the Python API. They have a Python API as well, and they have documentation on that as well. And it's pretty easy to use. And this is what I use personally, because I do not want to use the command line for stuff. So if you want to use, just have like Python code for each and everything, you can have that. Each and everything that it does. So you can delete runs, you can manage runs, you can manage what Guild keeps track of everything within Python itself. No need to go outside of Python. Yeah. So you can check that out for yourself. That's two. The last thing is, unless you have any more questions, last thing is training on multiple GPUs. Yeah. So for that, again, I'll create a new file. I don't need this. So, oh, so what do you use, and what I recommend you use for when you're training with more than a single GPU is something called distributed data parallel. I mean, there's something else in PyTorch called data parallel, but then don't use it. Even when you're using, so imagine, wait, so there are different scenarios. So the first scenario is you have one machine and you have a couple of GPUs on there. You have 2 GPUs, 4 GPUs, 8 GPUs on your one machine. Maybe it's a remote server, maybe it's your local machine. You have a couple of GPUs. That's the first case. Second case is wherein you have multiple machines. You have multiple computers, and each of those computers have multiple GPUs. And then you want to train on those. So say the first node, it's referred to as a node. The first node has 2 GPUs, second node has 4 GPUs, and so on. And then you want to distribute your training on all of these GPUs across these different nodes. That's the second case. In either of these, so usually what people do is they use data parallel. I mean, typically people used to use data parallel, but then even now, PyTorch themselves, so the guys behind PyTorch themselves recommend that you do not use data parallel. Like, don't use this. Like, whenever you see people using this, tell them not to use it. Use distributed data parallel because it's faster, it's more stable. I personally use data parallel. I mean, distributed data parallel. Uh, and yeah, and it does everything for you. So what are the things that you'll need when you're training on multiple GPUs? So you'll have your model on multiple GPUs. You'll do a forward pass, and when you do a forward pass, you'll and then you when you do dot backward, all the gradients will be calculated, and then you want to accumulate these gradients from all these GPUs, and so DDP will do that automatically for you. You do not have to do anything, just like minor modifications in the code. That's all that you have to do. Okay, so okay, yes. So let's do that. So the first thing that you need, let me close unnecessary stuff. Yeah, you need some import statements, and you'll have to do some. So there's some boilerplate code that you'll have to add, which does like basic stuff. So so PyTorch does not automatically know the entire setup that you have. So you'll have to specify that, and then there's some other environment variables that you'll have to set. Uh, I mean, it's pretty easy if you read the documentation itself. It's like extremely well written and it's very. But then we'll do it now so that you can see it happen. Uh, okay, right. And there is so in the quiz as well. You'll have to look at the documentation because I'm not going to talk about it during the lab. You'll have to look at the documentation, figure out how you can do something that I'm going to ask you to do during the quiz. So yeah, this is the this is the link to the documentation. So use that. And so it's not possible to go over everything that's going to happen like when you're going especially when you're using ddp you'll run into like a million problems because training on multiple gpus this will like millions of things that can go wrong. So every time something goes wrong you'll have to look at the documentation as to figure out what you're going to do wrong. So like okay, so what we'll need is a model. Firstly we'll need a model that we're going to train on multiple gpus. So let's create a model and let's do mnist because that's what we're familiar with. So uh, I'll type in the functions first. Okay. And I'll need a forward function. So I'll I'll just make a small coordinate, nothing complicated, like there's nothing to talk about here. Within the coordinate, I'll make this coordinate and we'll see how to train it on multiple GPUs. So everything, all this code will be like similar to what you have seen before. The only difference is when you're actually performing. So even in the training loop, there won't be any difference. The only difference is when you're actually like spawning processes. So we'll see that. So let me first fill in this. So you need a model that will take in an MNIST image, which is 784 28 by 28 image, and then it does image classification and returns one of 10 classes. So let's do that. So first things first. Uh, First layer. Touchstone 2D. If you see me mistype something, please do let me know. Because last time also, if you remember, I typed in 15 inside batch now, and we were trying to figure it out for 10 minutes what was going wrong. Uh, spool 2D. First layer. Let's copy this. Paste. Dixon. 16. So we have fully connected network, which dot. Okay. Oh no. I didn't mean to run it. No. Okay. So we have a coordinate that is going to do classification. There's nothing new here. Just a coordinate that is going to take in your MNIST image, do classification. Okay. So now we'll need a training script that is going to train. So first, what I'm going to do is I am going to let's first create a main function that is going to be called by each of your process. So wait, let me explain that first. So assume you have 4 GPUs. So what you're gonna do is you're gonna spawn a process per GPU. So there will be a single process per running per GPU. So you can think of it as I mean, kind of, you can think of it as the script being run 4 times parallelly. And so, as with anything running parallelly, you'll have to manage like how fast each is running, and each of these processes will have to communicate with each other. All of this is done automatically by PyTorch. You do not have to get your hands dirty with any of this. All you have to do is spawn the processes. Like that's all you have to do. Actually, the spawning the process is all you have to do. Everything else is managed by PyTorch. So let's create a main function, and this main function is going to spawn or train, and we haven't defined a train yet, which we will. Train function. um, we need two number of processes that we need. So how many processes do you want to spawn that will be equal to the number of GPUs that you have? So one process per GPU, and we haven't defined that yet, but we will. Arguments that we want to pass in. Okay. So now we actually need the arguments. Sir. Okay, arg parse. Resolved. Sir. Wait, let me first. Args. We have args. We need to add all the parser argument. I'll explain this once I finish typing. I'm not good at speaking and typing at the same time. Int. Oh my god. Bank. Okay, so we'll talk about that also. Some parameters that you need, and I'm just defining like default values for those. I'll explain what each of this is in some time. Let me explain it right now. So you are going to train on multiple GPUs, and how these GPUs are distributed. So like I was saying earlier, they could be on a single node, they could be across multiple nodes. And so this parameter that I have defined, which I'm going to use later, is nodes, which refers to how many nodes there are, how many machines there are. Are your GPUs on a single machine? Are they on multiple machines? So that is what N is. G means how many GPUs there are per node. So per one of these nodes, how many GPUs there are. And NR, so this refers to rank within the node. And how I'll explain that, I'll explain this part later because I'm not sure how to explain it right now. I'll explain it while I'm doing the actual training script, only then it will make sense. And epochs is what? Epochs, number of epochs, and then I have a parser. Yeah. And so something else that we have to do. So okay, so what will be the world size then? World size refers to the total number of GPUs. So total number of GPUs will be equal to number of nodes times the number of GPUs per node, which we have. So number of nodes times number of GPUs per node will be the total number of GPUs that you have, and that is what is referred to as world size. Like these are like jargon terms that is used in DDP, and so basically world size refers to number of GPUs that you have.
Can different nodes have different number of GPUs?
It can, yes, it can, but it will be it won't be as easy as doing this because then you'll have to configure it manually, as far as I know. Let me think. I think yes, it will be difficult. I mean, won't be difficult, but you'll have to do it manually. Like by default, I think it expects it to have equal number of GPUs per node, if I'm not wrong. Hmm. Let me think. No, I think it's possible even without manually doing it. I think it will automatically work. I mean, if you have multiple nodes with multiple, I mean, I haven't tried it out yet. Like all the test cases that I've done, there are equal number of GPUs per node. So I haven't really personally tested it, but then I mean, you can test it, I guess. But then I'm not sure. Like I can't tell you what would happen because I haven't tried it out yet. So you have to define two environment variables. Like so the thing is your script will be running across multiple machines, potentially multiple machines, and so PyTorch DDP expects some environment variables to be set. One of that is the master address, which is this. I mean, in our case, we'll just set it to be localhost, and a port. So this is kind of a rendezvous port where all your different processes can communicate at. And so typically when you're training on like huge clusters or something of clusters of GPU, then you do not manually set this. You It will be set automatically on the machines that you're gonna run. But then in our case, because we're running it on a local machine, we do have to set all of this manually. So what I'm gonna do is, I don't know if I've imported OS. Yes, OS dot environment master address localhost. Master port. All that you have to do. So this is the only part that you have to do yourself. Okay, I already have typed it out, so I don't know why I'm. Yeah, should be here. Right. So all that you have to do is actually spawn the individual processes. So the number of processes that you're going to spawn is one per GPU. So the total number of processes that you spawn is equal to the number of GPUs, and you'll pass in the arguments to each of the GPU, each of the processes, and what are each of these processes going to run? Is each of these are going to run an instance of train, which we're gonna define. I mean, right after now. Uh, and before you you know spawn the process, you have to make sure that these environment variables are set. In our case, we're doing it manually. In your case, I mean, it depends on case to case wherever you're working. In your case, you might have to do it manually, or it might already be set. Once you are like clear about that, then you should decide whether you have to set the environment variables or not. Okay. So I hope everything is clear so far. Like if you have any doubts, do ask because there's a quiz afterwards. Uh, okay. So now all you have to do is create a train function, and that's the hard part, because now you have to deal with there being multiple GPUs. So let's see. So this train function is going to be run by each GPU, right? Wait. So if you see, this train function is going to be run by each of the processes. So each of the processes will have to identify themselves. So like if imagine I'm running the same function 4 times, and it's running on 4 GPUs, and there has to be some kind of identification that, oh, I am GPU 0, I am GPU 1, I am GPU 2, and I am GPU 3. And in again the jargon for in DDP for that is something called rank. So I am rank 0 means that I'm the first GPU on this node. I'm rank 1 means I'm the second GPU. I'm GPU 1 on this GPU on this node. Similarly on another node. So if you have another machine with 3 GPUs, then they will have ranks 0, 1, and 2. It's just again a term that is used. It's nothing special. But yeah. And so, but then we'll have to keep track of it, because inside each of these trains, so I mean the functions themselves do not have any state, in the sense that they do not know that they're running on said GPU. So we use this thing to keep track of it. So rank will refer to what? Rank refers to the which GPU I am within the node. So that will be equal to times. So this is, I think it should be self-explanatory. So wait, let me try to explain this. So in one GPU, in one GPU, there are, so in one node, there are number of GPUs. And this refers to which node I am. And so if you multiply those two together and add the current GPU index, you will get a unique number corresponding to each GPU on each node. Basically, I mean, so all you have to understand is this rank, this value that will be stored in this variable, will be unique for each GPU on each node. And it's just a way to identify which GPU I am, so that eventually DDP can, accumulate all of this information. Okay, that's all that's important. And so now you have to do something called an init process group. This thing you have to do. I mean, you'll have to do this every time you're doing DDP. You'll have to do this. So dist dot init process group, and so the backend. Yeah, there's a lot of new terms. So the backend. So this is something called a backend. This glue is something called a backend, and there are multiple backends. So wait, so I'll explain this easily. So you have one GPU, you have a second GPU, and there's some computation happening on each of your GPUs. And there are different functions called like this all reduce. They're like common functions that you do, which will accumulate the information from all of your GPUs. And there are different backends that implement these functions, like all reduce, such kind of functions. There are different libraries. You can think of it as libraries or backends that implement this. So glue is from Facebook. So this is Facebook's compute backend for parallel processing. There's another thing. I mean, I typically use NCCL, which is NVIDIA's version of the same thing. If you just Google, so you can see it. NCCL is NVIDIA Collective Communications Library. Yeah, and the same thing, this glue as well, which is Facebook's. Wait, I don't think this is it. Glue. Yeah, this thing. Second, a collective communications library. It comes with useful algorithms that is used for parallel processing, such as all reduce, broadcast, barrier. Yeah, and so there are many versions of this, and the common ones are NCCL and glue. I recommend that you use NCCL, especially when you deal with NVIDIA GPUs. Use NCCL unless there's some reason that you can't use NCCL. And world size will be world size. Okay, and our init method, there's some stuff that you have to pass in, will be okay, and then you have to seed it. So I'm not pulling this out of nowhere. So this is stuff that you have to do every time. Every time that you do DDP, you'll have to do all of this. You'll have to do init the process group. You'll have to seed. I mean, so seeding is not really important when you're doing a single GPU, but then it is important when you're doing multiple GPUs. And then you have to, so let's initialize a model connet. Okay, so we'll have to set the device. So this is again something that's important. You have to set the device. So in our case, we have that in GPU. And then we have to force our model onto the set GPU. Okay, that's pretty much it. Everything else is the same. There's nothing else that you have to do. Everything else PyTorch will handle. Like this is the only boilerplate code that you have to add. So the first thing is that you have to set the environment variables. The important thing, the key points is that you have to set the environment variables. You have to have some kind of way to keep track of the rank for each GPU, which is a unique way to identify. It is a way to identify each GPU uniquely. And yeah, you have to call a dist.init process group, which I mean, again, you have to do this every time, and then you can choose a backend that you can use for the compute back. So there's different backends that you can use, and if you do not know what each of these are, just use NCCL. And then yeah, that's it. Then everything else is exactly the same. So again, you have to set the device each time. So inside each of these trains, so there will be 4 parallel trains. So assume you have 4 GPUs, there will be 4 parallel processes that are running, and inside each of those will you'll have to this will have to run basically toss.coder.set device. And then I moved my model. So each time so the model will be initialized 4 times, and so you have to move each of the instances to the GPU, to the corresponding GPU. Everything else is the same. Everything else that we've done so far, batch size. We need a loss. So again, for classification, it's cross entropy loss. And so make sure. So this is extremely important because otherwise it will throw like nonsensible errors and you won't be able to figure out what's going on. So you have to make sure is that when you're calling .CUDA, you have to specify which GPU it is, because otherwise it will load to the main GPU. So there'll be one GPU that is in charge of like accumulating all the information from all the GPUs. So if you just call .CUDA, it might not be a good idea. It might work, it might not work. So don't take the risk. You should always specify within your CUDA what GPU you are calling it to. I mean, you want to force your model to be in. You have your loss, then you need an optimizer. So .sgd, some standard learning rate. And yeah, I forgot one thing. So once you have your model on your GPU, you have to uh, enclose it within data parallel. I mean distributed data parallel. Distributed data parallel and model device ID is distributed. This is just again a single line of code that you have to add whenever you're using DDP. You have to convert your model into a DDP with a wrapper, basically with a DDP wrapper. So you can have a version of your model with the DDP wrapper and without the DDP wrapper. But then yeah, you have to do it. You have to do this every time. So wait, I'll okay. So when I add all of this, so when I actually share the collab notebook with Sir, I will add maybe a comment at each place where this is like something that you have to add explicitly only when you're dealing with DDP, and everything else is common. Okay, so what we have our optimizer, we have the model, we have the loss, we need a data set, of course, data set. Data sets. Uh, did I not import? Hmm, Torch vision. Oh, okay. You'll need a sampler as always. And again, this is again something that's different. So you'll need to use, I mean, it's not really different. Instead of using a sampler, you'll have to use a distributed sampler. Data dot distributed dot distributed. I hope I did not make a spelling mistake. DISTRIB, distributed sampler. And the number of replicas that you need is the world size, which is total number of GPUs. So wait, let me actually go to the documentation so that it's clear. Hmm, distributed sampler. Yeah. So you have your data set, and you want to pass your data to the GPUs. And this time, instead of a single GPU, you have four GPUs. And you want each of your GPUs to get different data, right? Otherwise, there's no point if you're passing the same data to each of the GPUs. Then you're not doing anything. Like it's effectively the same as uh, having a single GPU. So you need different subsets of the GPU that you want, subsets of the data that you'll pass to each of the GPUs. And so distributed sampler will do that automatically for you. It works smoothly with distributed data parallel. And so don't use normal samplers, use distributed samplers. And everything else is the same. You'll have a data loader, torch.utils, data. Uh, hmm, workers, that's fine. And this will be zero. We just need a single worker. Yes. So we have a data loader. Now we need the actual training script. So let's do that. For epoch in range. What do I call it? Epochs. Mm. Give me a minute. Just need to close my window shades. This is nothing you haven't seen before. It's just a basic training script. And you only want to print it once. You do not want to print it for each GPU. So you want to print uh, epoch, epoch, loss. It should be the total steps will be okay. And loss. Okay, and if you're done, if you want to keep track of times, then you can. Oh, okay. So maybe we'll have a timer so that you can see how the time will differ once you have multiple GPUs. So let me have a timer start as well. Okay. So then I'll print it. So we have everything now. So we have our loss, we have optimizer, we have the model, we have the data set, we have the training script, and I'm printing only when only, so I'm only printing for a single GPU because otherwise it will print 4 times, and which you do not want, or 2 times. So depending on how many GPUs you have, it will print in each of the processes. So in each of the processes, it will reach the statement, and so you only want to run it when it's for the first GPU. And then this, and I think we have everything. We have a train. This will be running on each GPU. We have the main. Okay, so then if you're we have everything. So first we're gonna run it with a single GPU and a single node. I mean, I do not have multiple nodes, so we'll only be testing one and one two case. So a single node, a single GPU. We are gonna train for 2 epochs, and everything else. Let's see. Let's try running it Hopefully there's no error. So, okay, yeah, first error. Store action got an unexpected argument. Oh, okay. Where did I type in default? Default. Yes, default. Okay, next time. Datetime has no attribute now, which is weird. Wait, what? Oh, oh my god. No, 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 no. Oh no. Wait, it is datetime.now, right? What is. Okay, okay, okay. I imported the module, but I didn't import the class. Okay. Where is it? Here. Okay, that should work. Third time's a charm. Or not. Hmm, let's see. I'm passing in the images. This is something wrong. Hmm, okay, maybe I messed up the model. Let me see. If you guys have any idea, please do let me know. Hmm, weird. So I have a single diamond channel, which is the case because it's black and white. Hmm, I'm not sure. And then in my training loop, yeah, just some labels. Weird. Yes. Okay. Somebody has an idea. Should be. Oh. Okay. Okay. Wait, wait. Wait, what? I didn't understand. Layer one. Oh. Okay. 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 Yeah. Thank you, Siddharth. Okay. Let's go. Okay. So it's training, and so this is what the one GPU case. Yeah. I've passed in. Yeah. It's one GPU. So next time we'll. It took 10 seconds. Now, hopefully, when I pass in two GPUs, it should take fewer than 10 seconds. Let's see. Yeah, it took 6 seconds. I mean, it won't be exactly half because there's time involved in accumulating gradients and reducing loss and stuff like that. So reducing as in I mean, yeah, averaging the loss between multiple GPUs. Okay, so pretty much it with DDP as well. DDP is it's not that complicated. It's just that there are so many points where stuff can go wrong. uh and yeah. So usually like from my personal experience where I've seen stuff going wrong is when you move data to the GPU, and if you move data to the wrong GPU, or if you load the model to the wrong GPU, or if you do not specify which GPU you want it to go to, then there might be problems because otherwise what will happen is all the data will be like all the models will be loaded onto a single GPU, and then yeah, the utilization for other GPUs will be low. So and this is just like scratching the surface of what DDP offers. Like it's a extremely well library. There's so much functionality in DDP, and so for the quiz also you'll have to find something within the documentation that I haven't mentioned today, and it won't be difficult. It's extremely common. It's like very commonly used function within DDP, uh, and yeah. So you'll have to find. So you'll have to look at the documentation and find out what function I'm asking for. It won't be difficult again. So you just look at the documentation; it will be there. If not on this page, it will be there somewhere. Yeah. So there's a search bar here. Make use of that. That's pretty much it with DDP as well. So I don't think like it will be a short lab today because it's only so much to discuss. We do not have any specific topic to discuss, so we save time with theory today. So unless you guys have any questions, that'll be it. Do you guys have any questions? Uh, And so I don't have a notebook right now, so I'll copy everything to a notebook and I'll share it with sir, which then he will post it on the website. I do not have I so like because I ran all of this on the machine instead of Collab, I'll have to copy paste it. Hmm, yeah. Okay. So if you guys don't have any questions, I will send the quiz link, and that will be the last quiz, and then we are done.
Sir,
Yes.
sir, would you be giving us any kind of hint for the
It's
project as well?
project.
It
Which
was
project?
in PDP only. So the course project, it was given a dedicated lab would be there.
Oh, you mean wait, I actually don't know what is going on the course. Okay, so let me just look at what you're talking about. This thing, this lab you're talking about. Oh no, not this.
No,
This class
no,
project.
not lab. Actually, in this website only, there is system development
Oh, this
only
thing. Uh,
uh, for the
class project. You mean?
creation of a project. Yeah, project. Yes,
I think
system
that
development.
is usually taken by sir only because last time, if I remember, he took it, and yeah. I mean, so what do you mean by system development? So what are you looking for? You want to know how to make a thing for this?
Yes, exactly. So how do we choose models?
What is sir asked you to do this time?
It is image to text to image generation. That's the project.
What? Wait. So why is he collecting celebrity images then?
Yeah, yeah. He has given face recognition attributes, and then we have to accordingly generate faces using the data given.
Oh, nice, nice. I mean, armed with all the stuff that we've done in the lab, I think it should be pretty straightforward, right? Like, there's nothing. Wait, so,
No, that is
yeah.
straightforward. I don't. But how do we means these are we have to integrate maybe two models? No, so that is the thing.
Yeah, so what is the
Text to
problem? So, like, when
generation.
if imagine you have a model and then you have another model, and then you can just take in the output of one model and pass it to the next model. Like, it's not really, there's nothing novel there. Like, it's usually done also. So, imagine you have two models. So, we did it in GANs, right? We took the
Yes, yes.
input of the generator and passed it to the discriminator. I mean,
Okay.
it's straightforward, right? Like, there's nothing new here. I don't think you'll have that much of a difficulty. Like, if there's like it's anything specific that you have, just email me or like message me on WhatsApp or something. Yeah. Okay, so I'll send the quiz link now because people are waiting. Started. Copy. Cancel. Just cross check the document before I send it. Yes, it's fine. I think. This will be 15 minutes. I mean, maybe you can take 5 minutes extra because this is actually you have to find something this lab. So yeah, so you can take 15 minutes. I've sent the link. If there's anything, yeah. So this is the last lab. So bye guys.